Welcome to APES Weekly. Brad Dunn here.
And I'm Will Smith. Let's kick things off with our weekly segment, Name That Term.
It's simple. We will provide the questions and the viewer attempts to answers them. Let's get to it.
Hello and welcome to Name This Term, where I go out and ask random people what words are.
Population dynamics. The changes a population undergoes in size of individuals, density, or individuals in a certain space, dispersion of individuals, and age distribution.
Can you define biotic potential, please?
No, I can't. Is it capacity for growth of a population?
Yes, it is. Thank you very much. Intrinsic rate of increase.
The rate at which a population would grow if it had unlimited resources.
Can you define environmental resistance, please?
All the factors acting jointly limit the growth of a population.
Thank you.
Carrying capacity, the number of individuals of a given species that can be sustained indefinitely in a given space.
Minimum viable population, MVP. The certain minimum population size.
Back to you, Will.
If you couldn't tell by those terms, our topic today is population. The reason we choose this is because our population has just reached 7 billion this past Halloween.
You know, there are actually 4 factors that affect population change. They are size, the number of individuals, density, the number of individuals in a certain space, dispersion, which depends mostly on resource availability, and age distribution, the proportion of individuals of each age in a population.
And with all of those factors seeming to favor us, we are experiencing exponential growth. Exponential growth is when our population increases faster and faster over time. And in a graph over time, it is basically graphed as a J-shaped curve.
On the other hand, logistic growth involves exponential population growth when there is a steady decrease with time as the population approaches its carrying capacity of its environment and levels off, making an S-shaped curve on the graph. An example of this type of growth is the sheep of Tasmania in the early 19th century when they leveled off because of the island size and availability of resources.
Thanks, Brad. We have an expert here with us today to explain to us about biotic potential of a population.
Thank you, Will. Well, put simply, the biotic potential of a population is the maximum rate at which the population can increase when there are no limits on its growth. The high intrinsic rate of increase is the rate at which that would increase. The 4 characteristics of a population with a high intrinsic rate of increase is that, number 1, they reproduce early in life. 2, they have short generation times. 3, they can reproduce many times. And 4, each of them have many offsprings each time they reproduce. Well, back to you, Brad.
Thanks, Troy. Lastly, we have a special YouTube video that we believe well illustrates density-dependent and independent populations. Take it away.
Density-independent population controls affect the population size regardless of its population density. Examples include fires, floods, habitat destruction, and pesticide spraying. While density-dependent controls are limiting factors that affect a population's density as it increases. Such examples include competition for resources, predation, and disease.
Wow, great video. Well, that's our show. Be sure to tune in next week for our musical episode about the mating habits of eagles.
Good day, everyone.
Thank you for watching.